Hello and welcome to learn about 3D printing. Today's topic is 3D printing in general, basically the introduction episode. In this episode or in this talk, we are gonna dive in on these topics. So basically we will dive in on 3D printing, like what is it? 3D printing compared to traditional manufacturing methods, 3D printing process in a quick glance, and what application could be in 3D printing, and what are the pros and the cons on 3D printing. So basically, what is 3D printing? It's a manufacturing process of creating an object from a digital 3D model. So basically, you will need a digital 3D model that you have made yourself with a 3D modeling software, or someone else has made it and you have just downloaded the file, and you put that file into a software called a slicer, and that slicer creates the paths for the 3D printer, which the 3D printer will follow and create the object in the end. So first you need the digital model that you need to then run through a software that creates you a file from the digital model that the 3D printer can understand. And then you put that file into the 3D printer, and the 3D printer will manufacture your file according to that created file from the 3D model. It's really simple process in the end. So from a digital model to a 3D object in real world. That's the idea of 3D printing. You have a digital model and then you run it through a software and then you put it on a 3D printer and you are left with a finished piece. So how is 3D printing compared to traditional manufacturing methods? For example, CNC. So when we compare subtractive manufacturing and additive manufacturing, in subtractive manufacturing, you will have like a block of material that you will then subtract some parts off from that from that block. So you will have your finished piece in the end. And that creates a lot of waste because you have to remove material. You will have a block, then you will drill holes or cut corners or stuff like that. And that creates waste. If we look at through additive manufacturing, so basically 3D printing, the material isn't like in a block form that you have to sculpt or machine it into shape. The material is in shapes that can be molded into an object. So basically material is like powder or some plastic filament, or it's some kind of a liquid. Something that isn't in a physical big block size. It's not something that you have to remove parts of. It's something that you can build out of. So basically the 3D printer will use that material, that powder or that plastic filament or that resin, and create the object out of that, which then again causes a lot less waste because there isn't much that needs to be subtracted. And in some cases, in additive manufacturing process, the waste that is created when you 3D print an object, the waste that is created can be reused. There's a possibility to recycle the waste. For example, when using plastic extrusion, you can recycle the waste that has been created. Basically, you will only get waste when you use supports in your prints. So that creates the only waste in plastic extrusion. But then there's the powder printing, which creates a bit of a waste too, but you can reuse like 70% of the waste. I mean, you can reuse all the waste, but you will need to mix some new material with the waste so it can be reused properly. So you need to have some new material included with the waste to reuse it when talking about powder 3D printing. This means that you can recycle basically not everything in 3D printing. You can't recycle the resins. With resin printing, you will create waste because of the supports for the prints, but that can't be recycled because the resin is cured, and you can recycle cured resin. That has to be properly treated as a waste. But powder and plastic filaments, those can be recycled. So what's the 3D printing process like? Well, it starts from an idea. You have an idea that you need something. For example, in this case, there was an idea to need Philips Hue remote was needed. It could be attached to the wall properly, replacing the light switches. So you could attach the Philips Hue remote to that. That was the idea. Then came the process of 3D modeling. So the idea fabricated into a 3D model using some measurements and stuff like that with a caliper or a measuring tape. After the 3D model was finished, it was exported into a format that the slicing softwares support. For example, 3MF or STL or OBJ file. And then that was taken into the slicer, that 3MF, STL or OBJ file. It was taken into the slicer and sliced. When it was sliced, after that, the software creates a G code. This 3D printing process is for an FDM 3D printer. This might not be entirely applicable to like other 3D printing 3D printing methods, but this is applicable for the FDM and mostly for others too, because they also start from an idea and the 3D modeling and etc. But after the slicing, there was a G code file created, and that G code file is taken to the 3D printer either with an USB stick, either through network or an SD card. And then the printer starts to print, and after the print is finished, we take the print out, check it if it's needing any post-processing. Does it need any sanding? Does it need any painting or stuff like that? If not, it's ready to put into use. So in the picture down there, it's shown that it's installed in its place and the Philips Hue remote is installed there. There could be another arrow going to this word called iteration. So you can create different iterations from the object, different versions with slightly different dimensions, because it might not be working in the first time. So you might need to make a few versions checking the dimensions. So there could be an arrow from the 3D printing process to iteration to 3D modeling, because you have to adjust the parameters on the 3D model. But then again, the process goes through the same steps, exporting to MEF, STL, slicing, printing it again, checking the dimensions, and if it fits and you're happy with the results, then it's a finished product. Those are basically the steps. Okay, well, applications. Where can it be used? These are just a few applications. Of course, it can be expanded to pretty much anything. But jewelers, for example, use as a help to create unique rings, amulets, bracelets, or earrings. It can be used in automotive industry. For example, Bugatti has tried 3D printing brake calipers. It has worked really well. And for example, BMW and Audi and Mercedes are also bringing 3D printing into their factories for using test technology to test out with new parts, or bringing out the possibility to give spare parts to old cars that the parts aren't manufactured in old traditional methods like subtractive manufacturing, but they could be manufactured with additive manufacturing, because it will require less work from the operator, and it will be more cost effective. Of course, it can be used in education. You can use it as a help tool for education. It's a great tool. 3D printing is a great tool for engineers for testing out prototypes. It's great for the medical, because they are now 3D printing hearts. They're 3D printing these little balls to help with hip surgeries. They help with joints for the tissue to grow, effectively on the surface of the joint. It's usable in rehabilitation because you can 3D print unique or tools that help with the rehabilitation. It's a great tool for architects. For example, you can 3D print your model that your client wants you to design a house. You can 3D print the house and show it off before any construction has been done, because there might be some design things that the client might want to check on. And of course, it's a more of a wow effect that you have something physical to show than to show through the screen of your computer or through a PowerPoint in a presentation to the client of your design building. Some bakeries have started using that, and some, because you can create such unique cake molds, for example, and you can 3D print chocolate, for example. And some education facilities started checking if it's possible to include 3D printing in their pastry education program. Shoemakers, soles, you can make those for your clients, so you don't have to do them by hand. You can first 3D scan the client's feet and then create the 3D model of a sole for that. Not the sole, but the part on which the shoe is created upon. But then again, you can also 3D scan the shoe, for example, that the client has, and then you can create unique soles. Aviation is used in basically with for making the planes more cost effective, because there's the weight reduction, and that will have high impact on the fuel consumption when there's less weight with the airplanes. For designers, basically it's the same with the engineers, a great help. And hobbyists, it's taken really big steps to that direction too, that many hobbyists can have a 3D printer in their home, and they can connect their existing hobby with 3D printing. They can create parts that have costed a lot of money, but now they can create them for like pennies, those little spare parts that they use in their own hobby. But what are the pros and the cons of this so great manufacturing method? Well, pros are you can create very complicated shapes. Each product can be individualized. There's no need for molds because the printer creates the parts from nothing. The iteration speed. So you can just print something and notice that there's a little dimension error. There's a little measurement error. You can change the 3D model, put the printer when you leave work, and the next morning you come back to work, the print is ready in the printer. Complicated shape was that you can create shapes and geometries that you basically cannot create in traditional methods. And then there's the less waste, of course, because there isn't much waste created, and freedom of design. There comes the straight and waked aspect. You can create more organic shapes which do have more strength, and you can put connections and material in the places where they're needed, and you can subtract from the 3D model the material where it's really not needed. So you can optimize your models a lot. So what are the cons? It's very slow for mass productions, unless you have like a 3D printed farm. Then it can be on par with some traditional methods. It will always lose with injection molding because of the speed of injection molding and the cost of it. I mean, there are some 3D printing manufacturers that claim that they are on par with the injection molding, but it's a future to see. There's less material options, so not every material can be printed right now, and mostly for normal materials, for like ABS or PET, you need a certain type of a printer. And for like Peak or Ultem or POM, you need a certain type of a printer. So you need basically different printers for different materials. Not every printer, I mean, when I'm talking about plastic extrusion, There's different printers for different materials. You will need like a catalog of printers to have all the materials covered. For example, metal 3D printing. Not every metal is 3D printable yet, but it's growing. It's growing. The material catalog is growing in each 3D printing technology. All the material options. I mean, it's a growing number. And then if we compare to a molded or a CNC'd pod, I mean, same pod, if it's 3D printed or CNC'd, it's a bit weaker. I can't say probably how much weaker, but it's a bit weaker than a molded or CNC'd. It loses in accuracy because the printers can't get exactly the same accuracy as like a CNC machine or a molded pod, because those are really accurate. But when we're talking about accuracy in 3D printing, we are still talking about like 50 to 60 microns, or even less, or like 20, 25. It really depends on the printer. Reliability of equipment and the difficulty of use in certain situations. Yeah, so 3D printers are like just any other equipment. It can break down. There can be issues. It's not so simple in the end, but nothing is ever very simple. In a like positive aspect on this reliability of equipment and this difficulty of use in certain situations, the spare parts for 3D printers isn't that high cost. This was a short introduction to 3D printing, like what it is and what's the applications and stuff like that. In this video, it wasn't covered like wholly. This was just a glimpse to 3D printing. There's a whole lot more information available, but hope this was an informative package to you. Have a great day and see you in the next video.